SwayamPrabha. Digital India. Educated India.
Good morning, welcome back to the discussion on product and portfolio architecture. In the last class we discussed about portfolio architecture, what are the different types of architectures in portfolio, and what is the method by which we can decide the number of products in the family as well as the individual structure of the product. So that is what we discussed in the last class. So today we will move to the product architecture. So the portfolio talks about the family, but then product architecture talks about individual products. How do we actually identify the architecture of an individual product? We saw that the product architecture is defined as a scheme by which the function elements of a product are arranged into physical building blocks and by which the blocks interact. So we need to check how these individual building blocks can be identified, and then how can we have a proper interaction between these individual building blocks. So as I mentioned earlier, the functional blocks need to be converted to physical blocks, and then these physical blocks need to be identified which are the functions that can be combined or which are the functions need to be kept separate. So that actually decides which are the building blocks, the physical building blocks, and based on that we will decide the architecture of the product. And this also we saw that we can actually have different modules in a product. Okay, if it is the modular one, we can have different modules. So these modules are the chunks which actually provide a set of functions in the product. So it is the physical chunks which become the building blocks for the product. So the architecture basically depends on the ability to offer product variety. Okay, so if you want to have multiple products in the family, then the individual product architecture also should satisfy that requirement. So we should be able to provide a family of products without making too much of changes in individual products. So that is why we need to know how this is going to affect the ability to offer product variety. Similarly, how is it going to affect the product cost? So if you want to make every product as individual one without much of sharing of components, then the cost will go up. So we need to make sure that without increasing the product cost, we should be able to offer the product variety, and accordingly we need to have the product architecture, and then the design lead time and the process management also. So these are the factors that will actually affect the product architecturing. So let us look at these products what you are seeing on the screen. So if you look at this product as an individual product, you can see that there is only one physical chunk in this product. All the functions needed in this product, the spanner is actually provided by one physical element. There are no multiple elements, there are no parts, and all the functions. So it has all multiple functions. It has to hold the nut head, it has to apply the torque, someone has to hold it, or we should be able to use this for tightening or loosening of different size of nuts. So we can actually see that all these functions are actually combined into a single physical block. So that is one type of architecture we can think of, where all the functions can be mapped to a single physical block or a physical chunk that can actually provide multiple functions in the product. So that is one type of architecture you can think of in a product. So all these products, so they are in the family. Okay, they are actually a family of products, but each individual product you take, this individual product is having only one physical chunk that provides you multiple functions. And then of course this is in the family architecture. If you take the portfolio, then there is actually an unshared architecture. There is no sharing of anything in between these parts. Now take the example of these products. It is also doing the same function of a spanner. Only thing, this is an adjustable spanner, so you can actually have you can use it for tightening or screwing of different size of screw head, the nuts or the screw heads, bolt heads. Now if you look at these products, you can see that it is actually not a single block. There are three elements in this one. So, there is an adjustment screw here, and there is this movable jaw, and then you have a physical block. So, you can actually say that it is providing this function using 2 or 3 elements, and then if you want to have a different size for adjustable size, you can actually use the same screw, the same kind of handle. Only thing that you need to adjust this part which actually need to have a larger size or a smaller size. So, this way you will be able to provide multiple functionalities, and the functionalities are actually provided using one or more elements. So, here actually there are more physical chunks which actually helps you to provide the function. And similarly, you can actually see this one. So, here all the individual products are actually having multiple elements, and when you combine these multiple blocks, you will be able to provide the main function in the product. Individual elements will be having its own function, but when you combine these multiple elements, the handle, the head, etc., if you combine, then you will be getting different functionality. So, that is one way of the two ways in which you can actually develop individual products. Other examples are like an aeroplane if you take. So, you can actually see that this engine, there will be a slot in the main assembly where you can actually attach engine. So, engines of various configurations can be connected to this one. Similarly, the fuselage, the wings and other things, each one can be considered as a physical chunk which provide a particular function, but then you combine all these physical chunks, you will get a overall function of the product. So, these are the two major architectures you can identify in products. So, we call this as an integral architecture. So, when there is only one physical chunk which actually provides you the function needed in the product, then we call it as an integral architecture. When there are no multiple elements, only a physical chunk, mostly one physical chunk is providing all the functions, then we call it as an integral architecture. And if there are multiple physical chunks when which combine together you give you a product, the product function, then we call it as the modular architecture. So, integral and modular are the two important architectures that can be thought of when you have a product architecture. So, these are the main architectures used for designing products. So, integral one will always look at combining all those functions into a single physical chunk, and modular look for different modules which individual functions and then combining them in different ways to get the function of the product obtained. So, these are the two major architectures for products, a modular and integrated architecture. So, a modular architecture, the chunks implement one or few functional elements in the entirety. Each functional element is the physical chunk, that is the modular one. So, you have multiple physical blocks, physical elements implementing the functions to get the overall function of the product. Then the interaction between the chunks are well defined and are generally fundamental to the primary function of the product. So, if you have multiple physical elements and the function of each one is well defined, and you know that how this can actually be integrated to the main building block. For example, if you take this set of pen, so each pen or the mechanical pencil, you know that there are multiple elements, each one has got its own function. The body has got some function, the tip has got its own function, and the control one has got its own function. So, each one has got its own function. So, each one is a physical block, and when you combine these physical blocks you get the function of the product. So, that kind of a architecture is known as the modular architecture. But contrary to that, if you have an integrated architecture, the functional elements of the product are implemented using, so in this case a single chunk implements many functions. So, you have one single chunk which actually implement many functions in the product, and the interaction between the chunks are ill defined and may be incidental to the primary functions of the products. So, that is the way how the integrated architecture is defined. So, you can take an example of this pencil. So, you can see in this pencil one chunk which actually provides many functions in the product. So, almost all the functions of this pencil are provided by the whole chunk, though there are multiple elements in this one, but each one is everything is combined together into a single element and it provides the function. It is very difficult to identify the interaction between them, how each element is interacting is very difficult to identify. For example, this lead at the tip and the wooden block. So, all these are actually integrated and there is no separate interaction between them, or there is no separate interfaces between these elements. So, that kind of an architecture is known as an integrated architecture. So, these are the two major types of architectures that you can see in the product, and most of the time, as I mentioned earlier also, you will see more products in the modular architecture, because that helps you to very limited products using integral architecture. So, these are some of the examples for this architecture. So, let us just take the trailer as an example. So, you will see these kind of trailers which are attached to the trucks to carry loads, or it can be attached to the truck and then you can take it. So, now if you look at this as a product and as a in its architecture, you can see there is a box which actually is to protect the cargo from weather, and there is a hitch which actually connect to the vehicle. So, which is the hitch. Then there is the fairing, which this is known as the fairing, which actually provides the air drag reduction. Then there is a bed at the bottom, then the support the cargo loads, then the springs which actually suspend the trailer structure, and the wheels transfer loads. Now, you can see each physical block has got some function to do, and it does that function, and when you combine them it provides the overall function of the trailer. So, that is the typical modular architecture where you have multiple modules. Now, if you want to change the fairing, so you feel that okay, it is not providing you enough air drag, or there is a case where actually that is not a critical factor, then actually you can remove it and then you can put something else there. Similarly, if you feel that the spring the suspension part is not doing well, or it needs to be modified for a different application or another product, you can easily change it and get a new product variety in the market. So, that is the modular architecture. Now, if you have the same as an integral architecture, suppose you think that okay, the trailer can be made as an integral architecture because you have a large requirement for this. So, you do not need to make separate parts, not need to assemble. So, you can have it as an integral architecture where you will be having a structure like this. So, now you can see this is the integral architecture. So, you have the upper half, lower half, you can actually identify upper half, lower half, nose, cargo, hanging straps, spring slot covers and wheels as the elements. But you cannot really identify them as a separate, each one doing a particular function, because all the functions will be actually it will be doing multiple things, and you will not be having any separation between these individual physical chunk. So, each physical chunk may be doing multiple things and there is no definite interface between these elements. So, that kind of architecture is the integral architecture. So, you can see that upper half is actually can be protect cargo, it can actually support cargo loads, it can actually suspend trailer structure also. So, there may be many things which actually this element is doing, and very difficult to tell what actually each physical chunk is doing in this case. Together they provide the function. That is the integral architecture that you can see in this case. So, the same product can actually be designed with a modular architecture or an integral architecture, but that depends on what the final outcome that we are looking for. So, in this case, if you are not looking for any large variations in the product, and you can actually give the same product to everyone, so you do not need to make it separate different assemblies because or different modules, because you are not going to change any modules to get a different product. So, that kind of situation an integral architecture is one of the best option for products. But if you are expecting a change in a variety of the product, or people are looking for various options in this particular product, then it should be always good to go for a modular structure, so that you can actually modify some of the modules to get a new product to meet the customer's requirements. So, the design whether to go for a modular or integral depends on various market dynamics, as we mentioned earlier, but these are the two architectures you can always consider when we are going for a product design. So, this is another example. So, if you look at this product what you are seeing here, can you identify what is this or what could be what actually this represents? You can see there is a tool tip and there is a mechanism to apply some force and there is a mechanism to increase the force here and that can be do some cutting operation here and there is a spring which can actually bring it back also. So, if you look at your nail clipper as a product, then you will see that this nail clipper is actually having if you take that as a modular structure, then you can see these are the elements that can actually have it in a nail clipper, because you can have a element which a function a blocks which actually can use the apply force, a block which can actually increase the force and then get the spring back, and then it is a block which can actually provide the cutting tips the tool tip, and this way and there is a base which can actually be used for applying the force using our finger applying the finger force. So, if you look a nail clipper as a modular structure, then actually you will be able to get this many modules, but most of the nail clippers are not designed in modular architecture. They are actually made in an integral architecture where you do not need to, you cannot really change each one of these, because the functions are actually shared between the physical chunks and then you will not be able to get a clear differentiation between the physical chunks which provide the functions. Okay. So, if you look at the same as clipper, you can actually, so this is the nail clipper in an integral architecture. So, this is an integral architecture where actually the physical block provides all the functions, and it is very difficult to distinguish between the different physical blocks and their individual functions, because there will be lot of sharing of function between the elements and then you will not be able to see it as a individual modules. So, that is the integral architecture and this is the modular architecture. And as I mentioned, a modular one is always preferred or most of the time a modular one is preferred, because the modular the modules allows us to provide product variety. So, depending on the portfolio architecture, you can actually take a call on whether to go for an integral or a modular architecture. This also we briefly mentioned what are the factors that affecting the modularity affecting architecture modularity. So, the product changes. So, if you think that the product may change after some time, then you may have to go for a modular one, and there is a variety if you are expecting a number of varieties to be brought into the market. Similarly, the standardization of components, suppose there are some standard components available for some particular functions, then you can actually buy those standard elements, or you can develop the standardized components and then use it. So, in that case you cannot you do not have much of an option, you have to use those standard modules and then develop the product. And then of course, the performance, because the performance of integral architecture and modular architecture may not be the same depending on the number of modules and the interfaces that you need to provide. The performance may degrade in some of the modular architectures, and some of the some performance cannot be achieved in the integral architecture. So, looking at the product performance, again you need to take a call on to have the architecture. And then of course, the manufacturability and product development management. And if you make everything as integral, then the manufacturing will be a problem. So, you may not be able to manufacture it in the form of an integral architecture. You may have to make it multiple elements and then combine them. So, that also need to be taken into account when we have to decide the architecture of the product, and of course, how long it will take, how many people may be needed in if you go for one architecture to the other architecture. So, that actually comes from the management aspect also. So, looking at all these, you need to take a call on the architecture development or deciding the architecture. Now, there are two ways to look at the modular architecture. So, since we found that modular is the most popular one, so we look into the modular architecture and then see what are the different types of modularity normally provided in the product or normally adopted in the product development. So, one is known as the function based modularity. That is, based on the functionality of a product and how these functions are distributed, you can identify the module. So, for each function you can identify a module, and accordingly we can develop modules and then make the product. That is basically known as the function based modularity. But the other modularity is basically on the manufacturing based modularity. So, some of the products may be requiring a lot of manufacturing, and there will be different manufacturing techniques that can be used for this. So, depending on the manufacturing easiness, we can decide, okay, this particular module is easy to manufacture. So, let us make this as a particular module, and some part can actually be manufactured using a particular process, then all those which requires that kind of a process can be put into together as a module. So, this way, depending on the manufacturing requirement, we can identify modularity. So, these are the two kinds of modularities normally employed in the product architecture, that is the function based modularity and manufacturing based modularity. Now, this modularity, if you look at the model architectures, so there are different ways in which this modularity can be achieved in the product. Now, assuming that we are going for a modular architecture, we can actually think of 4 types of modularities that can be brought in the product, that based on mostly on the function based modularities. So, what we do is we look at how these can actually, the modules can actually be combined together, and based on that we will identify the modularity. So, one of the most common modularity is known as the slot modularity. In slot modularity, what we do is that we will have a basic assumption, you have a basic platform available onto which we want to add modules. So, that kind of modularity where we provide some kind of slots in the product. So, we provide a slot, this kind of a slot, or we provide a slot like this, and then we can actually add components whichever component actually meets this slot, we can add to this. Similarly, we have a product which a module which actually has got this slots, or a component with this slot. So, this base platform, so we call this as the platform, base platform, and these are the slots available. So, any module with a slot like this can be attached to this product, that is the slot modularity. So, if you take an example for a aircraft, so you will see there will be a slot for an engine. So, any engine which actually has got this kind of a slot can be fitted to this particular aircraft. Similarly, you have an air conditioning system, and any air conditioning system which has got a slot like this to suit to this product can be fit into this. So, it does not matter whether who is manufacturing it, what is the other specification and all, as long as this actually matches the slot that is available, you will be able to fit into this product. So, that kind of modularity is known as slot modularity. So, you can actually see many products in this format. If you take your power tools, electrical drills, hand drills or any other electrical drills, there will be a slot for a electric motor. So, as long as the motor has got a slot or interface suitable to this machine, you will be able to connect any motor. So, it does not really matter what kind of motor. So, as long as it is actually having the same slots, you will be able to connect. So, that kind of products are having this slot modularity. So, this is one of the commonly used modularity in the products, especially in the modular architecture, you will be having this slot modularity. So, another one which is commonly used in computers and other electronic products are known as bus modularity. So, bus modularity is that you have a platform. So, you have a platform, and in this platform you have one slot. So, this slot is having a a common slot in this. So, this is known as the bus. Okay, so, the basic connecting element is known as the bus. Now, any element which has got a slot, I mean interface slot like this can actually come into here. So, it can be anyone, it can be like this, or it can be like this, or it can be like this, or anything can actually come into this, as long as the modularity is the slot is same. So, for example, in a computer there will be a bus which connects. So, you can actually connect a RAM, you can connect a hard disk, you can connect a communication device. So, anything can be connected to this bus as long as the slot is like this. So, that is the bus modularity. So, in bus modularity your interface is the same, and any module with that interface can actually come into this. In the previous slot modularity there are multiple interfaces possible. So, you can actually have multiple components with that kind of an interface can actually go into the product. So, that is the slot modularity and bus modularity in products. And this is the bus architecture. So, you have the same interface, okay, bus modular architecture. Here you have multiple interfaces. Now, another one architecture is known as the sectional modularity. Sectional modularity is that in these two architectures you have a base platform, or a base structure to which you add the modules. So, that is the bus modularity and slot modularity. But in the case of sectional modularity there is no basic structure. So, everything you have what you have is a module. So, you have multiple modules, and then when you combine all these modules you get a structure. Okay. There is no basic structure to which you add modules, but every module can actually become part of a structure. So, that kind of an architecture is known as sectional modularity. So, sectional modularity you can see that each one is an individual module, but then they have the interfaces, and you connect these interfaces, I mean these modules to form a structure. So, that you can actually have different structures identified, or you can develop different products based on this kind of architecture. So, this typical example is the furnitures, office furniture. So, you can see office furniture there will be basic platforms, you have basic modules, the top plate, the legs, and then the support plates, etc. And then you start assembling them in different ways, you get different products. That is basically the sectional modularity. So, you have sectional modularity where there are no basic elements or basic platform, but every module contributes to make a structure or a product. That is the sectional modularity. And the last one is the mixed modularity, where you can have a combination of all these things. Okay. There is no specific modular structure here. You can have a slot modularity, a bus modularity, or a sectional modularity, and then when you combine all these you will be getting a product. So, most of this Lego kits, if you might have seen the Lego kits, so you will see that you can actually combine the different modules or different blocks and get a structure, and each one will be having either a slot modularity or a bus modularity or a sectional modularity, and then you take each one of these and then assemble them properly, you will be getting a product. So, that kind of thing is known as the mixed modularity. So, in any individual product architecture you can see this kind of modules or the modular structure, that is either a slot modularity or a bus modularity or a sectional modularity or a mixed modularity happening. And what kind of modularity you want to provide in the product depends on again the product and all other factors that we discussed. So, the designer can actually take a call what should be the modularity they want to provide, and many cases there will be both slot and bus modularity, because if you take even computer you will see that it is a combination of slot and bus modularity, because all those processors and other things will come under with the bus modularity, or the connection to the processors and the RAM and things like that will be using a bus modularity. But then the other elements like your USB drives or your power supply units, these can come under the slot modularity. So, not that you can use only a particular one. So, you will be always having a mix of the slot or bus modularity depending on the product and the other aspect where actually what kind of modules you want to offer in the family. So, that is about the product architecture, the two types of product architecture. The first one is an integral architecture where you have one physical chunk providing the overall function and multiple functions in the product, and in the modular architecture you will have different physical chunks, each one providing a function, and then when you combine all these chunks you will be getting the total function of the product. So, and again you will be having within the modular architecture you can have either a function based or a manufacturing based modularity. So, that completes the discussion on what are the different types of architectures you can have. Now, the question is that how do we actually decide the module? Suppose you want to go for a modular architecture based on requirements of the product and the customer's needs, you decided to go for a modular architecture for a product. The question is how do you decide the module within the product? Yes, you can have you will be having a lot of functions required in the product, and then you need to know how these functions can be grouped together to have physical blocks. And if you are actually combining all those functions into a single physical block, it becomes an integral architecture. And if you are actually trying to make them into different physical chunks, then it becomes modular. But then how do we actually combine these functions to make them individual blocks, or how do we actually decide the number of modules and the elements within the module? So, that is the next question. So, here we use two methods to get the modules. The first one is known as a basic clustering method, and the second one is known as module heuristics. So, the basic clustering method, what we will do, we look into the functional block of the product, and then based on our own understanding we try to group them together. Some of the blocks we will say, oh, this block seems to be common, or it has got many things common, and therefore we put them together and then make it as a module, and that is basically known as the basic clustering method. So, without any logic or any particular rule, we start clustering them and identify the modules. That is known as basic clustering methods. And the second one is the module heuristics, where we try to use some kind of a logic or heuristic method to get the module. So, that is the module heuristic. So, there we use some kind of a rule to say that okay, if these things are there, then you made them together. So, that is the module heuristics. First, let us look at the basic clustering methods, and then we will see the module heuristics. So, in the basic clustering method, the steps involved in getting the module are: the first method is to create a function structure. So, we know what is a function structure. So, using the flow methods we can create a function structure. That is the first step. So, any product you try to identify the functions using the flow method. So, we will identify all those the functions and then see how it is going. So, of course, there will be energy, material and flow going, and similarly you will be getting energy, material and flow coming out. So, using this you identify all those functions needed in the product. So, that is the function structure. Then cluster the elements into module chunks. Now, based on this you cluster these the functions into modules, provided they share a common primary connection. So, combine as many subfunctions into a module, provided they share a common primary connection, material, energy or signal. So, you look at this function and then see is there something common in all these functions. So, if you can identify a few functions which actually share something, either a material or an energy or flow, so you try to see whether you can combine them. That is the first step. Combine as many functions into a module, provided they share a common primary connection. And then if standard interfaces exist, choose modules such that these interfaces are congruent and not split across modules. Standard interfaces are either the communication interface or mechanical interfaces, where you need to have a transmission or mechanical conversion, electrical to mechanical, or mechanical transmission of the mechanical power. So, such things require some kind of a physical interface. So, if you can see such interfaces, then you put them together. So, that all those things require a particular interface can be put together, so that it can be easily interfaced with the other modules. So, that is the thing. If interface standards exist, choose modules such that these interfaces are congruent and not split across modules. And take into account the expected changes in technology. Suppose you think that the technology is going to change, or a particular technology you have used for some function in the product, and then if there is a possibility that this technology is going to change in the future, try to make it as a module, so that when the technology changes you can change the function, the module also. So, that is what actually it says, take into account the expected changes in technology, and then take into account the portfolio architecture also. Suppose you already decided the portfolio and you identified that there should be 4 products, and there is a requirement of a low cost and high quality or high capacity, then keep that in mind. Suppose you need to change the capacity, then you can make that the capacity part can be a module, so that you can have different capacity, so that you can have different products. So, that is the way how you can think of considering the portfolio architecture in the product architecture decision. So, the second step is clustering the elements into module chunks based on these criteria, any of these criteria or multiple criteria. So, you may have to do it 2-3 times, because you will be doing it first based on the sub function, then you look at the standards, then you look at the changes in technology, and then you finally decide, oh okay, this can be a module, this can be a module, and whichever cannot be converted into modules, that will make it as the base platform or a part of the base platform. So, you will have a base platform to which other modules can be added, and this module again can have it as a slot modularity or bus modularity or a mixed modularity. Okay, so, that is the way. Then create rough geometric layout. So, once you did this module, then you create a rough geometric layout. Okay, you can say, oh, this is the paper handling module, and this is the power supply module, and this is the control module, and this becomes the chassis. So, like that you can have the rough geometric layout and hierarchy of the product architecture from the function structure, map the hierarchy to 3D or 3D sketches, and alternate layouts can be considered, and layouts be refined including ergonomic and aesthetic information. So, that is the stage where actually you identify these modules and then try to give them some shape, create 2D 3D models, and then try to see whether that actually matches the requirement or matches your expectation, revisit it and refine it as you feel as necessary, and then complete the architecture. So, that is the first method of basic clustering method. Hope you understood this, and let us take a very simple example and then see how to do the basic clustering methods. So, as I told you, the material interaction, energy interaction, information interaction are the one which need to be can be considered while we trying to identify the modules based on the functional architecture. So, if you have materials are flowing, then you consider that as a module. There is an energy which actually be transmitted or shielded, then basically look at that aspect. Similarly, information and spatial interaction. Spatial interaction is basically the dimensions, degrees of freedom, etc., etc. Okay, so let us take the example of this inkjet printer. We already saw this inkjet printer earlier, and we discussed about the functional decomposition. So, here we will see we saw the function structure also. So, let us see how we can use this function structure to identify the modules within the product. Now, okay, this is the example for the inkjet printer function structure. So, we saw that the input electricity, then ink, then human energy and paper, these are the main inputs. Then of course, the input data, air and power supply, the other power supply is already taken into this. So, these are the main inputs and these are the outputs. Okay, now, and we have this blocks here. So, these are the different function blocks. Now, as an individual and again it is a basic clustering method, as I told you that we do not follow any particular rule per se, but we will follow the guidelines where actually we will try to follow the the material or energy or flow, the signal in flows, and see whether something is common between all these functions, then you try to make it as a group. For example, you take paper, then you see that okay, paper is doing here, 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 and then this one, and the handling. So, there is something common between these blocks. Similarly, there is something common between this energy part, and there is something into this ink part. So, like this we can identify, we can look at this individual thing and then see whether we can group them together as a module. What we will do, we will look at this electricity first. So, as I told you, the electricity part, you can see you have this electricity, connect electricity, actuate electricity, supply power, and then display status, and then they process the data. So, this all becomes part of something called electrical or electronics module. So, we can think that okay, since they are all common to this electrical and electronics, which is very much distinct from the other functions of the product, probably we will be able to make this as a module. So, that is the way how we try to see. So, this can actually be considered as an electrical or an electronics module. And then we will try to see whether something else can be identified. So, you can see this is store ink, jet ink, and display ink level, and support ink handling modules. So, this again you have the common flow in this, the ink as a material which actually is common to all these functions. We will try to see whether we can put this as a module. And as I told you, this is only the beginning of the identification of modules. So, it need not be necessary that all these modules will be there in the final product. We are trying to see potential modules that can be identified. And so, you will be having another one as the paper module. So, you will be having the import paper, store paper, choose paper, increment paper, etc. as another potential module. And we have another one like remove heat, capture vapor, filter flow, and these things, air intake air and other things. So, that can actually be either can be make it as a separate module, or we can say that is part of the basic structure. So, that it need not be a module, it can be an integral with this one also. Anyway, in any case we can actually say that okay, this is another thing which can actually be thought of combined function which has got common things to with them. So, these are the potential modules that you can identify in this product. Now, okay, so you can see that okay, this is the electronics module or electrical and electronics module. So, this can be the ink system in the product, and this is the paper handling system, and this is the chassis. Okay, but this basically that's the structure of the printer. We do not need to make it as a separate module. So, you can actually be part of the chassis or the body of the printer. So, this way we will be able to identify the modules. And again, as I told you, it is the designer's job to properly identify the modules based on the common flows in these functions. So, that is the first method. Now, once you have this, then you can think of making a rough geometric layout to see whether that actually meets your expectations or your requirement. So, now you have a paper handling module, you have an electronics module, and you have a ink module. So, these three modules need to be assembled in the product as modules. And again, of course, this is the component hierarchy. So, if you look at that one, you can have paper handling system, ink system, then chassis, and then the electronics. So, these are the modules that you can identify, and in addition to that you need to have a base and a chassis. Okay, base is to connect all these modules, and the chassis is to provide a cover or a supporting structure for that. And each system you will be having these elements, ink system, and then you have the chassis, the elements. So, now you can see the functions have been converted to physical elements. So, it is no more a function here, the product is actually trying to identify the physical chunks or the components of the product. So, slowly we are moving to the from the functional elements to the physical elements. So, we are trying to identify the physical elements, or we are trying to give names to the physical elements which provide the function in the product. So, the paper handling system takes care of all these the functions needed, all functions needed for the paper to be handled, and individual parts take care of the individual function that we identified in the functional decomposition. So, that is the way how we can convert the functional blocks into the physical blocks of the product. So, now we have a product hierarchy. So, this is the hierarchy of the product that you can see. And now we know that okay, these are the modules to be there in the product. So, we can consider these are the modules and these are the components that actually forms the module. Now, we can say oh, you have a print cartridge carriage, a paper handling mechanism, and then you have an input tray and output tray for paper acceptance, and this is the base, and this forms the chassis. So, this is the way, again a very rough geometric layout we can say. This is for the designer to understand okay, how it will be, how it can be actually assembled or how it can be organized within the product. So, you have a rough geometric layout of the product. So, this is the way how we actually move from. Now, if you look at the design process, so we had the functional blocks, and now based on the functional blocks we identified the modules, and based on the modules we identified the components, and now based on this we have a rough geometric layout of the product also. Of course, we still do not know how what kind of a base to be provided, what kind of handling mechanism to be provided. We are trying to identify the physical elements that need to be there in the product to meet the requirements. Okay, so this is the first method of where we try to identify the modules based on some basic clustering methods. So, but the limitations are that there is no systematic procedure for identifying modules. So, we left it to the designer to say that okay, oh, you identify a module, and he based on his own understanding and his own way of identifying module, he identified the module. So, there is nothing to say that whether it was correct or not, and because there is no rule to follow. So, that is the problem here, no systematic procedure for identifying modules, and families and module interactions are not well defined. So, here we cannot really define the interaction between the paper module and the electricity module or the electronic module, what kind of interactions need to be there. So, that is not really identified. So, there is to overcome these issues, we are going for the next method. So, the module heuristics actually try to overcome these issues in the product and in the clustering methods. So, before going to that, let us take a simple example and then see again how to identify the module. So, here you can see this is the pencil sharpener which we discussed, electrical pencil sharpener. Again you can identify the inputs and the output flows here. And if you go for the basic method of clustering, we look at the flow. So, you can see there is electricity flowing. So, you have this electricity common to all these blocks. So, we can say that oh, this can actually be made into a module. So, that can be made into a module. That is one way to do it. Then you can look at the pencil, okay, all the functions which actually connects can actually be made into a pencil module, or this can actually be separate because this actually talks about the shaved pieces coming out. So, that can be considered as a module. So, and the other things can be considered as the chassis. Again you can have a either you can think this also as a separate module because you have a electrical to mechanical conversion and then mechanical energy transmission also. So, if possible we can consider this also as a module. So, this is the way how we can identify various modules in the product. Right. So, this one you can do it as an exercise, you can try it yourself and then check whether this is working well, and then you can think of how to identify the architecture. So, a geometrical architecture you can think of how can a geometrical architecture can be decided based on this, and what are the modules and the components that can be thought of in this case. Okay, so, we will stop here, we will discuss the module heuristics or the heuristics based modular decomposition in the next class. Okay, thank you.